Alright, so for this problem, you have a table of values that's separated by females and males. But for part B, you're going to pretend like females and males aren't labeled. You're going to put all the MRI scores here and here all together in L1. So you should have 10 scores in L1. Then you're going to put all the IQ scores in L2 all together. So all of these and all of those. So you should have 10 MRI scores and 10 IQ scores, 10 in L1 and 10 in L2. So then you'll run stat calc 4 with L1 and L2 using all 10 of the data values. And that gives you a regression of 0.679677, etc. So rounded, that would be 0.680. So that's where the 0.680 comes from. Now, whether or not they're linearly related, you have to compare the number you get to the chart. And the chart is in your formula booklet, or you can look on the pop-up attachment here. So for 10, we're comparing the number we got to 0.632. The number we got is greater than 0.632. So the answer is yes, they are linearly related. So we use 10 for the first sample size because we put all 10 values in L1 and L2. So for part B, the answer is yes. And your correlation coefficient comes from your calculator when all 10 are entered. Now for part D, it wants you to compute them separately. So we're just going to do the females. So I'm going to go back into L1 and only do these 5 in L1 and L2. So I'm going to go back into L1. Sorry about the glare. The first 5 entries should be good, but then I'm going to delete all the male entries. So I'm going to go after the 5th one, I'm going to delete those 5. So you can hit delete, 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 or you can hit clear and then delete, 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 delete. So I have the 5 female MRI scores and the 5 female IQ scores. Then stat calc 4 again. We're going to get a different correlation coefficient. And it's negative this time. So that's where the negative 0.831 comes from. It's just having the 5 females. Now this time, n equals 5. So I'm comparing the 0.831 to 0.878. So this time, the 0.831, and you don't need the negative, you can ignore that. Just the 0.831 is less than 0.878. So it's not linearly related. It's not bigger than what's in the chart. So even though it's a pretty strong correlation coefficient, we're saying because the sample size was so small, that's not good enough. So we're comparing to n equals 5. We're going to do the same thing for the males. So for the males, we're going to just put these guys in L1 and L2. So I'm going to go back to my calculator, clear out what I have in L1 and L2. Remember to push clear, not delete. Clear what I have, and I'm just going to put the males in. 955003, 949589, or whatever your numbers are. They'll change every time you do the problem, which makes it a little tedious. 1038438. The numbers will not be this big on the test, I promise. 935494. Whoops. And then 139, 144, 135, so forth. So just 5 for the males. Then we're going to do stat calc 4 again. Down to calculate. The male correlation coefficient is where we got that 0.069 from. So if you just look at the males, they have a pretty crummy correlation coefficient. If I compare that number to, again, that n equals 5 number. 0.069 is much less than 0.878. So it's that same n equals 5 number from the chart. So again, not linearly related. So all 10 together make a nice scatter plot. Looking at them separately, not such a good scatter plot. So that's what all of this is filling in the actual correlation coefficients, what you get from the chart, and whether or not it's greater than or not greater than. And if it's not greater than, no relation exists. So it should be a little bit easier to fill in, hopefully, now that you know where those numbers are coming from.